Welcome, soulmates. It's time for episode 6, which we're calling Unearthed, and I'm joined once again by superstar producer Claire Mackenzie. Hi, Claire.
Hi, soulmate, superstar, host of the podcast and producer, Richard Tufton. Nice to see you. Where are you, Richard, right now?
Well, I'm sitting in Madrid in Spain, where I've snuck away for a little working break with my family, which is quite fun, enjoying some freshly baked bread every day and locally sourced fruit and vegetables. They have an amazing food scene here, which has been quite fun. But you and I just got to spend a little bit of time together at Groundswell, which was excellent. And I was curious how you felt Groundswell went this year.
Yeah, well, first of all, it was, for the podcast, amazing to see you in person and not this usual virtual hello. And Richard is real, everyone. And so we had a particularly special moment because Richard we didn't, 6 Inches of Soul did not have its own home as such, tent, but Richard did with his business and where he works, and he works alongside the glorious Gabe Brown. It caused much excitement because I was telling people to meet me there, and then they'd walk in and go double take and then point like that, it's Gabe Brown, and I'd be yeah, it's Gabe Brown, and they're like, you're so casual, it's Gabe Brown. So everyone got to meet Gabe Brown, and which is he was the first ever guest on the podcast, but B, obviously his book featured in the film. And the wonderful thing is he is the very essence, as many of these wonderful people are in this world, of just fully grounded, wants to talk soil, wants to talk regeneration, gives you a hug, makes you feel better. So he signed people's books, and it was really special. I think if that, for me, probably sums up Groundswell, it's meeting up with old friends, reconnecting, old new friends, obviously last 5 years. But for me, that was my 5th one. So from the 6 Inches of Soul team, sadly we had none of the main stars. Anna, Ben and Adrienne have all been on the podcast, sadly weren't there because they're busy with lots of things in their lives. But just to announce to everyone, we are going back on their farms in the next couple of months, and then we will reveal those updates of our videos for everyone to see. And so that's really exciting. But there were a few of the team there. Mel, who played a huge part on the impact and still helps out with distribution. Lucy did lots of research and impact. She was there with her beans hat on. Elsa was back from Kenya. She'd helped hugely with behind the scenes with research. So there were various people there. And sadly, Colin wasn't there, the director. He was in Canada with his family. But we still had the most wonderful times. Who did you see, Richard?
I enjoyed bumping into Jeremy, who did the 6 Inches of Soil book, which was kind of a big part of episode 1 of the podcast. It was all kind of around the book launch time. So it's good to see him. We also had a team from Roots Coffee, Marcus and Will, which was excellent to see them doing some good business, selling lots of coffee. But yeah, I think to your point, it was just everybody is so grounded and down to earth. I think that's the end of my soil puns. And it was just good to see them and hug them and talk to them. Just human to human contact it was great. It was also really interesting to see who the attendees were this year. And I really noticed that there were many more downstream people there, meaning it wasn't just farmers, it was people buying the food that the farmers are producing. So there were many more buyers from some of the big supermarkets and retailers and cafes and, brands, ingredients manufacturers, people like that, which is really interesting because I think it shows that we're starting to bridge the gap from a niche thing to something that's becoming more mainstream as more and more people start to understand the power of regenerative agriculture. So that was really encouraging. And then, of course, we had some good hang time with the Fielden team, who very generously sponsor the podcast. And so we got to hang out with Dave as Claire holds up her Fielden Fields Full of Life tea towel to camera for those watching. So, yeah, it was great. It was really great just seeing people in the flesh. And also there was a special guest appearance of HRH, Prince William, announcing Gabe on stage, which was quite a special moment. And so that was good and brought even more attention into the space in a really good way. So, yeah, very positive. So who do we have on the episode today? Claire, you brought with you a couple of guests. Who did you bring?
Well, I'm going to announce Andy Neal, who I did get to see at Groundswell. He's the only one from this podcast, this episode, sorry, he was there. But it was great to hear him. That was a particularly good session on glyphosate. And he was on the stage with previous guest, Tim Parson, and also star of our film, Ian Wilkinson. And that was a really interesting discussion, discussing how to finish off after cover crops have grown, and you dealing with weeds or plants in the wrong place. So there was a lot of discussion, ploughing, glyphosate, crimping, the whole thing. That was fascinating. So got to see him, which is amazing. And we mustn't forget, we also, while we were there, and I was excited, and I'm being, before we announce more guests, is that I gave him, as Richard also did, lots of our new badges, which I've got one on here. They're little pins. That this was your idea. Why did you do it? So I know. Just tell everyone.
Yeah, well, Blue Peter, for our British listeners, was a big part of my life when I was little, which I'm now 6'5", but once upon a time I did used to be little. And part of the program was that if you went on, it was a children's BBC program, and if you went on, you got given a Blue Peter badge, which was this little like lapel pin. And if you got it, A, it was really special because it meant you'd been on Blue Peter, but B, it gave you like access to this whole new world. You could get, I don't know, I guess free entry to museums and stuff like that. And it became this kind of little exclusive club. And for some reason, that's a really strong nostalgic memory that I've got. So I thought it'd be a fun idea to do something similar with the podcast. So if you're a guest or connected to the pod, we were giving out the 6 inches of soil badges, which says in microscopic font soil mates all around the outside of it too. Hopefully as a bit of a badge of honor for those who have been on, and perhaps, conversation starters if you wear them at dinner parties or the like. So yeah, we were able to do some official presentations of the badges to guests, which we filmed a bit of content for, which we'll put out in due course. So yeah, that was quite fun.
So my other guest, so Andy Neal, is a microbiologist, been based at Rothamsted in the UK. And he, he'll describe his work's phenomenal. I've been with him at many events. What is incredible about him is he's a scientist, but is able to bring to life this subject in a very down-to-earth, sorry, another pun, way. And most of us might go microbiology, scary, crikey, without having that deep scientific knowledge. Will I be able to understand? But as everyone will hear, he's very good at that. And then Karen Johnson, also an academic based up at Durham University. And when I met her enthusiasm, love for the soil literacy element of life is incredible, but she's also an engineer. So it's kind of fascinating how she's swung into this space, but is passionate and shares some incredible work with us, which we will put on the notes, and we hope that you enjoy reading into both of their works as when we share them. And for you, what did you bring?
Well, I wasn't content with having one person called Andy on the podcast, so I've also found an Andie Marsh in Austin, Texas, who's one of my friends, and she has an amazing blog called Soil is Sexy. Having two guests both called Andy was one of the more confusing episodes we've done, but we figured it out. So Andy's on, she's a soil specialist, and she's all about composting, introducing worms into the system. She's a really interesting, as you'll hear, guest. And then we had an absolute superstar in this space. The others are superstars too. I don't want to show favoritism, but Ray Archuleta, who is one of the stars of Kiss the Ground, which I think for many people in this space is a kind of seminal moment of how they got into it. He was one of the stars of that documentary. He also, from a personal point of view, it was through him that I really got into this world. I saw some of his videos of water infiltration tests and Slake tests, which we go on to talk about in the episode. And I was very lucky to be at an event with him last year over in the States. And he, similar to Gabe, he's extremely down to earth, really friendly, and just has enthusiasm to want to share all of his knowledge. And he's just a really lovely human. So I was very touched that he said yes to appearing on the podcast. And as I'm sure you'll hear, his energy and enthusiasm for the topic is insane. And I think I referenced it in the episode, but it was recorded at 7 a.m. and he was just so ready to go and on. So it was great. So anyway, without further ado, please enjoy episode 6, Unearthed. Well, welcome, soil mates, to 6 Inches of Soil, the podcast. We realised that, I'm not even sure what episode this is that we're recording today, but we hadn't done one on soil itself, and that felt like a real opportunity to dive in and get some experts and people that have definitely taught me a lot about soil, especially in the last few years. A couple of whom I'm lucky enough to call my friends. So we've got Ray Archuleta here in the States, and Andie Marsh, Andy IE, which will become clear, I'm specifying that. And over in the UK, we've got Andy Neal with a Y, and Karen Johnson. So welcome all of you, and thank you so much for being with us here today. Andie Marsh, I'm going to share with listeners that you have a soil blog, which you call Soil is Sexy, which is an epic title. And I was curious if you could tell us a little bit about your journey into soil, what you blog about and share about, and how you think about kind of teaching everybody about soil, what it is and why it's important.
Sure. I remember first learning about soil microbial life during my undergraduate program at Texas A&M University, and being just blown away and actually getting to look at the critters under the microscope for the first time. And it just completely transformed the way that I looked at soil. I really thought it was a substrate that was lifeless, but, physical in form. So seeing it come alive before my eyes was life-changing ultimately, and changed the path of my career. So I ended up getting an internship at a vermicompost facility shortly after that, and just kind of kept pulling on that thread and wanted to start sharing all the information that I was learning through different books and courses, and sharing that just with friends and family. So I started a simple Instagram account and I titled it Soil is Sexy, because that was my goal, was to make something that had felt like a snooze fest in certain classes and make it something that was very interesting and captivating in the way that we communicate about it. So instead of focusing on really mundane aspects of soil only, although there's a lot of important aspects of soil outside of biology that we do need to be mindful of, but really bringing that biological component to the forefront and sharing that with people through media, whether that's visually or the written word. And that's what's evolved into my Substack blog now, still by the same name, Soil is Sexy.
Yeah, so you mentioned there looking at soil under a microscope. I know that's something I've never done. What are the kind of things that you see when you're looking at it at that kind of magnification?
Sure. So the magnification we look at is 400 times magnification, and you can see bacteria at that level. And those are going to be the smallest things that you can see. So you can't see a virus or anything, but you can see all of the things that actually prey on bacteria. So flagellates and amoebae and nematodes, these are the very charismatic characters underground that are moving quite a bit under the microscope. And you can follow them around and watch them consume bacteria. And ultimately, that action is what produces plant available nutrients such as nitrate.
Yeah, and I think that's so important to kind of make that definition about what is available to plants in the soil. But whilst we're still on the kind of microscopic level, and Andy Neal, I was going to ask you a quick question. I saw a clip of I think you call it a fly-through of a talk you gave a few months ago, and I was wanting to, well, obviously briefly introduce who you are, but tell us what a fly-through is, because it was really interesting to me. It was as if I was in the movie Honey, I Shrunk the Kids and back down, kind of traveling through the little gaps in the soil. But yeah, share us what that was about.
Okay, so my name's Andy Neal. I'm a soil microbiologist at Rothamsted Research, and I'm very interested, I suppose I'm very interested in developing a theory of soil as a habitat for microbes and understanding how that habitat influences the way microbes respire and metabolize. And that's very important in agricultural soils because of the way we manage them, and because we use a lot of fertilizer in one form or another. and how microbes interact with that can really influence the efficiency that's used in agriculture. So, that's a real interest of mine. Those fly-throughs were created from some real soil. So we work with some colleagues at the University of Nottingham. They use a technique called X-ray computed tomography. And we use that to visualize pore space in soil, because the pore space is really the most important part of soil, because it's where biology, water, and oxygen are all mixing together. But of course, it's very difficult to convey that space to people using just a lump of soil in your hand. So we were very keen to try and find new ways of conveying this space and understanding how it changes, and also the consequences for it changing. And so we developed these using those X-ray computed tomography images. We worked with someone that was had skills in computer gaming to put a skin over effectively the images, so that we can then effectively the animation flies through different soil pore spaces that are from soils that have been managed in very different ways. And I find it a very effective way of communicating how pore space is very dynamic, and also to demonstrate how management sort of influences with this for good or bad. And so, I think without that sort of imagery, it will be very difficult to convey a lot of the work that we're doing.
Yeah, and I think that's a really good point. I remember learning it's something like 66% of healthy soil is air, or something in that region, and how dramatically you can improve the soil's ability to just infiltrate water. I'm fortunate enough to be friends with Gabe Brown, who I'm sure many of the listeners will be familiar with. And when he took over his ranch, the soils were dead and he could infiltrate something like 1/2 inch of water per hour. But having done regenerative agriculture, he's got that number up to about 32 inches of rainwater per hour, which for him is kind of a moot point, because he's up in Bismarck, North Dakota, and he only gets something like 16 inches a year. But the point is that every drop that falls on his land gets into the soil and is therefore available to the plants, to the roots all year round. And you look at how his farm does compared to his neighbours, and it's really stark, the contrast and the difference. Ray, coming on to you, I mean, I was fortunate enough to listen to your keynote last year up in Minnesota, and you described the soil as being the mouth. You said that the plant is the mouth of the soil. So I was wondering if you kind of talk a little bit more about that relationship between plants and soil, and why that aspect is so important.
I think it ties in beautifully with Andy. When I went to graduate school for soil physics, I thought it was fixed. That's not, it's dynamic, that the plant does so much. The ancient people used to call the plant the mouth of the soil. And what we meant that without that capturing of light and transforming it, in the words of Dr. Christine Jones, into liquid sun, to feed that myriad, to create the aggregate, to completely change the geology. Without living plants and microbes, imagine what these plants are doing. They're transforming this geological matrix. That's why I love studying the aggregate with great researchers. Have been people like Andy and these other people that have really helped us communicate the power of the plant and how we need to have living plants 24/7 as much as possible. And that's why we used, Andy, that rain simulator to reach scientists and engineers. And this is the biggest thing. Who would have thought that the water cycle ends with an aggregate? It is completed with an aggregate. It's not going to the river, to the lake. It goes into the ocean, into the soil. So I think that's why I use that term and make it very simple with farmers. The plant is the mouth of the soil. As soon as you get your corn and soybean, cover it again. Living plant, putting energy. That's the way the soil eats. That's a major source. We know that organic matter, a huge percentage of organic matter buildup is through living roots and in this biology. So that's why I convey that the plant is the mouth of the soil. Without that, You just got geology, period.
And you talk about the rainfall test. You want to explain exactly what that is, and we'll definitely post a video. But for me, that there were two moments which got me deeply interested in soil. One was seeing your rainfall test, and the other one was seeing the Slake test that I saw a YouTube video. So perhaps you could briefly explain to our listeners what those two things are.
Thank you. It was the USDA. There was an agronomist, Bud Davis. He created a machine where, if you look at the machine, it's got a pan. Each pan is about 1.5 inches in thickness, and each pan, imagine, has holes. So we want to measure the two most important things for farmers: infiltration and runoff. And one of my biggest statements is that we don't have a runoff problem in the globe. We have an infiltration problem. Cannot get the water in the soil, no aggregation, the water runs off. So we capture water. The big rain simulator has glass jars on the front, plastic jars in the front, and on the bottom, we capture infiltration and we make it rain. They call it the rain simulator. And what I love to call it is how nature works, the 4 ecosystem processes. I can show that. And what I mean by that is we'll have on one of the pans, we'll have a green cover crop on top. We'll have a forest soil. I use nature as a standard. We'll use a prairie grass, a regenerative farm, and we'll even use organic and conventional. So it's got 5 pans, and we'll make it rain. And it shows what our land does to the aggregate, to the pore space, the destruction of organic matter, and how we manage. It is a powerful tool. It is probably the only way, Andy, I can reach people. I'm just telling you, it's the only way. And then the Slake too. In 1930s, we knew about aggregate stability. It wasn't a new thing. But the aggregate stability is where we get a clod of soil, a PED, and we put in this little screen and we use this tall cylinder and we drop it in because we know we got millions of pore spaces. A good, healthy soil, when water rushes to fill the pore spaces, will not fall apart because of the superbiotic glues created by biology and life. And that aggregate is so precious. And so a good, healthy soil will stay clear as the water rushes in to fill the pore space. In a very diminished, lacking organic manner, the aggregate, the pad will just start to blow up and dissolve. And you can see the sands and silts and clays fall into the cylinder. Those things have been one of the most powerful ways to teach for us to reach scientists, government officials, and any person, farmers, and I think Andy can contest to that. It's the only way I can make statements and get away with it without that demonstration. It's the only way.
Yeah, I think that's great. And so you said the keyword forest soil there, and Karen Johnson, I'm going to come to you now because getting ready for today's recording, you briefly introduced a little study about forest soil versus sand pit plate, and I wanted you to share that with our listeners now, I think.
Yeah, thanks, Richard. Yeah, it's not my study. It's Maria Rosland from Finland, but it's a beautiful study. So what she was looking at was the response of children to playing with soil, and she was looking at their immune response. So she set up a lovely experiment, if we can call it that, when it's working with nursery school kids. These were 4-year-olds. She had roughly 30 kids who were playing in a sand pit, and they were playing for about an hour a week for 2 to 4 weeks. And then 30 kids who were playing in a sand pit that had forest soil mixed into it. And she did the whole Zoe microbiome test, the gut microbiome and the bloods. And she was looking at immunity, and she saw a statistically significant result, which means that even with those small numbers, we can be confident that there was some difference in the kids' immune system, and it was a better immune system that the kids who'd been playing in soil for it was just after 2 weeks, actually, when I looked it up after we chatted, that she saw the response. And so, yeah, we don't know yet whether that response is because kids have touched the soil, inhaled the soil, or eaten the soil. They weren't encouraged to eat the soil, but it was safe to do so if they did, because it was a healthy forest soil. So there's still a bit more work to be done, but it's just an amazing group that works there in Finland, and very exciting to spread that message about the fact that touching, a healthy soil, something like a forest soil that we know there's no contamination in there, is really good for our immune. system and good for our gut microbiome. And the thinking is because it directly affects the gut microbiome. They had evidence for that.
Blows my mind, and we'll post stuff about that on our social media feed, so we can listeners can dig a bit deeper into that. But sticking with you, Karen, I often get asked about what the difference is between healthy soil and unhealthy soil, and I guess smell is a big part of that. And I was wondering if you could kind of share your experiences with that.
Yeah, so I'm not an expert in smell, but I've become increasingly interested in the fact that in our soil health tests that we have, various ones like the Slake test that Ray's talking about, which is really good, and infiltration, which of course is super important. I noticed in one of Ray's videos, he was looking at smell when I was looking at your videos yesterday, Ray. But people don't talk about smell enough, I think. And I know that Ray knows, and I've found through smelling lots and lots of soils now since I've become interested in this, that good soil smells good, and it's the chemical geosmin, which is made by bacteria in the Actinomyces family, I think. Andy Neal, you can correct me if I'm wrong. And that smell is the smell that you smell when it's rained after it's been dry for a while. And you can actually smell rain like that even if you're a couple of miles away from a forest or a healthy soil. And that's because our noses are super sensitive to it. So I think there's a lot of room to bring in other senses when we're thinking about soil health, because that's another excuse, of course, for people to touch the soil and actually engage with it as a living organism.
Yeah, and presumably that's quite a good way to kind of engage with kids and get them thinking about it. I know you've done a lot of work in trying to bring the knowledge of soil to the sphere of kids and children's education. So, I mean, tell us more about your work there.
Yeah, so that's my passion is teaching people about soil. We did a big survey about 5 years ago now, just before COVID, of 1,500 school kids aged 13 to 15. And we found out there was two major gaps in their knowledge about soil, which isn't surprising because adults don't know these two things either, which is that soil is living and that soil is intimately linked in a two-way reciprocal relationship with climate change. And so this was quite concerning to us. And we also not only looked at their understanding of soil knowledge, but we looked at attitudes and behaviour. So we crafted some questions. It was obviously an interdisciplinary project working with sociologists to help us craft the questions to see what people's attitude, how they felt about soil was, what their behaviour with soil was, and what their comprehension of soil was. So we called it the ABC of soil literacy. And you can think about it more of as heart and hands and head. You know, it's a nicer way to think about it. And so on the back of that, when we found out the kids didn't know these things, we started to create, we got some funding from the Royal Society, I should say, which we're very grateful for. And we started to create resources. It's a charity up here in the northeast of England called Oasis, which stands for Outdoor Activity and Sustainability Education Specialists. And they are fantastic. And they've been working with me in creating amazing resources for age 8 to 11. And so we teach those 4-year groups with resources that teach them about how soil is good for you, healthy soil, how soil holds on to water, how soil is essential for underpinning all terrestrial life, all the things that we've been talking about. And then we're going to see what difference those resources make. Basically, what we're expecting is that they will then have better attitudes and behaviour to soil. And it's a longitudinal study, so we're going to go some way, hopefully, towards showing that those resources help people to have better attitudes and behaviour towards soil. But it's exciting because if you see the 8-year-olds, 7, 8-year-olds, they are mad keen to touch the soil and they have no qualms. Their attitude and behaviour around soil is wonderful. And then you get to the 11, 12-year-olds and certainly the 13-year-olds and they're like, I don't want to touch it. Give me some gloves. What's that thing in the soil that's wriggling? And it's sad. So it's a really exciting project, working with primary school kids.
I think the wiggly worm, I've got a 9-year-old and a 7-year-old, and they are definitely obsessed with wiggly worms. And in fact, Andy, i.e. Andie Marsh, didn't you you've done some work with worms and growing them, right? To introduce them to make soils more healthy. Is that right?
Yes. Yeah, that was one of my first hands-on experiences that kind of got me hooked on soil health and composting and all of that. So I've always had an affinity for things that wriggle and just that it does feel very much like a playful space. Like I've always felt like my job in that regard is very playful, because I get to interact with these wriggly worms or insects that we're finding in and around the site.
And so tell us more about...
Yeah, Rich, can we interface with each other, or are we just stuck with these? Because you know what, Karen? I get so excited, Karen, what you're doing. But let me tell you, have you guys buried, like getting white cotton underwear and burying them? What we do is we bury white underwear and bury in the health. Excellent. That is such a good, Karen, I love that test. And I'll tell you why. It is one of the best tests to teach about nutrient cycling. And a lot of times we get stuck with one parameter, like organic matter. Farmers just get so excited about it. I said, no. That's just one indicator. You know what I want? I want you to be able to walk into a field, you trip, and you come out naked because your soil is cycling. Then I know you're there, because then it provides the nutrients. It creates the aggregates. Cycling. And so that's why it's so cool, Karen. That is awesome that you're teaching those kids like that. So thanks for letting me interface, but I just had to say that because I think that is, visuals are so powerful. And that's one, I just love that underwear test. I want to do that more often.
So that if I can come back, Richard, to Ray there, that's one of the tests that the kids are doing, and they absolutely love it. So we've got them burying white cotton underpants in the soil, and of course it has to be cotton because that's come from plants, and that's what the soil microbiome eats. It's the food for the microbiome, just like we need food. And they love it so much, and they're super excited about coming back and digging up the pants. And the funding that I'm looking to get in the future is to do this across the UK, because of course it's quite a nice soil health test for across the playing fields where children are lucky enough to have a playing field that they can do this on. But yeah, it's really engaging for the kids, and of course it is a proper scientific test. You can replicate it, and as long as you know the cotton is the same, it is something that you can do analysis on.
Andy Neal, what about tests that you can do with farmers, and how are you finding the best way to engage with the farming community in the UK?
I think we're stuck at the moment in kind of between some of the old methods that people have used and the new methods that we would imagine we would like to develop in the future. I spoke at the beginning about how pore space is so important to us. We have a real problem visualizing that and measuring that in the field, and I think at the moment that's a big stumbling block. The way farmers can look at their soil in the field, the variety of different ways. Digging holes is just a very good way of doing it. Just getting down there and looking what's going on, and you can often see whether you've got compaction at depth. So just by digging holes, also looking at worms, earthworms, and the number of earthworms you find, although it sounds quite trivial, it is actually scientifically that there's now been a meta-study published probably about 5 or 6 years ago that has shown actually measuring earthworms is one of the biological ways of looking at soil that is practical as well, that actually is meaningful. So there definitely is a good, robust evidence that earthworm numbers does relate to quality and the status of your soil. But of course, with all these things, you've got to make sure you do it consistently. So you look at the same time of year or when the soil is roughly sort of equally moist, because lots of those environmental things will change earthworm distribution. But I suppose the most important thing, whatever you do, rather than just looking at soil and out of context, I think it's always important to compare it to, in the UK, we might compare it to what's going on underneath a hedgerow where the soil has not been disturbed for a long time. And I think that comparison, rather than just choosing the best measure and just measuring it in the middle of the field, is probably much more instructive for a practical in-the-field farmer than just the context of where the soil is compared to an undisturbed system. It doesn't have to be a hedgerow, could be a woodland, could be a pasture that hasn't been disturbed for a long time. But that sort of comparison, I think, is really important.
Yeah, and I think a big thing is farmers can only manage what they know. And I talk to many, many farmers across the world every day, and very few of them really understand their soil, just because they've never really been given the data or the soil test results or the water infiltration results to know that. And so that's a big part of it, is just providing that extra level of information to a farmer to help them, manage their livestock better, or their crop rotations, or their crop cover, and all of those kinds of things. But Andie Marsh, coming back to you, what about, you're not a farmer, but you're just a home gardener?
Can I say something about Andy's work, Richard?
Please do. Hit us, Karen.
Yeah, I was just going to say, because Ray mentioned the epiphany that he had in his 40s. It was similar for me about biology. I haven't done biology. I'm not a microbiologist. But I read Andy Neal's paper in 2020 about how soil structure was created by the soil microbiome largely, and of course the mesofauna and worms, etc. And it made my research make sense, because my research is about adding organic matter and minerals at the same time to soil. And the results we'd been seeing were it increases the infiltration rate, it increases the carbon storage, it increases the way plants take up nutrients, etc. And we couldn't work that out because the effect was greater than the sum of the parts. And then when Andy talked about emergent systems and I think the word is extended composite phenotype, which I definitely had to look up, Andy, because I'm not a biologist, but it made complete sense. And the analogy I always thought of was, you look at a bird's nest, you look at a small bird's nest and a big bird's nest, and you don't have to be a birder to know that the little bird's nest is made by a little bird and the big eagle's nest is made by a big bird. And it's ecological engineers, and that's what the soil is. And so I had my epiphany because of that paper. And ever since, I've been chasing the microbiome and trying to get to work with microbiologists like Andy and Andy, both of you.
Yeah, it's so important, just getting that extra level of knowledge. And I'm really so happy that you connected with Andy Neal. That's amazing. Andie Marsh, so if you're a home gardener and you're not a farmer, but you've maybe got half an acre, maybe you've got a vegetable patch or something, maybe you're thinking about doing some composting, what are a few kind of easy things that you can do? Because I think a lot of listeners are probably going to be in that boat. What are some of the easy things they can do to try to kind of engage in this regenerative agriculture movement and putting life back into the soil?
Yeah, I kind of think of the actions in two different categories. And for lack of better terms, I'll just categorize them as there's some abstract things that you can do to be part of this movement, and then there's some really practical hands-on things you can do. So the abstract things are very much about re-examining your relationship with the soil that you have access to, with the land that you have access to, the plants that you are surrounding you currently. So that might look like starting a sit spot practice, which is something I've learned from a field ecologist, where you go and you visit the same spot daily, ideally, or on some regular basis, and you're just an observer in that state. And that can really ground you into the changes that you might see across the season. It might help you reframe if you have historically felt anger towards weeds, for example. That might actually reframe your relationship with certain plants or certain insects that you maybe once feared. And I really don't want to, this is a really important part, I think, of becoming part of the regenerative movement and really changing the culture around soil, like what the general public is doing to participate in this movement, because we're so dissociated at the moment at scale, with not having those kinds of daily interactions with nature. So that would be step one. Another abstract example would be taking stock of your plate at dinner, at meal times, and really taking a moment to think about where the food came from, because those are the subtle moments where you'll start making better decisions, or just different decisions. You'll start finding unique ways to incorporate locally grown food into your mealtime, rather than just taking for granted what you can get at the grocery store, which may or may not be aligned with the kind of regenerative practices that we're talking about today. As far as like pragmatic things that you can do, I always encourage people to start small, because you don't want to overwhelm yourself. You want to have a successful, positive experience. You want it to be fun. You don't want to overwhelm yourself with too much to manage. So if that means you're starting in a pot, so be it. That's great. And really planting seeds, watching something germinate and grow can be a really magical experience if you're a first-time gardener. So many people that get into a gardening practice are just in awe of the changes that they see in the single plant that they start with. So I would say that's probably the best place to begin. And then composting is also a really magical practice where you can see things like this example of burying the underwear in the soil. You're really seeing food waste transform into a rich humus that is going to amend your soil in a way that is participating in this biological natural cycle of nutrient cycling. That can be really exciting for kids too, because there's lots of bugs around a compost pile. So I find here in my community gardens, that's the best way to get the kids engaged, is to take them over to the pile, and we pull the sheet back and see what critters are, scatter, and we dig into it and see if we can find worms, and we smell it to, because it smells nice. And then we check on the areas where we could put maybe some rotting food a week prior and check in and see that it's really degrading. And it's really kind of a magical experience to witness things rot and return to the earth.
Yeah, that's actually quite a good point. Karen Johnson, again, getting ready for today, we spoke about soil, not the idea of composting, putting energy in, but actually the idea of removing topsoil for construction and it going to landfill. And I wanted you to share a little bit about that, because I think it's a really important topic, which until talking to you, I hadn't even thought about at all. Before we get to the answer, we'll be right back. Take it away, Tilly.
6 inches of soil is made possible by...
Fielden is the English whiskey that's changing farming for the better. Field by field, harvest by harvest. Fielden is bringing England's fields back to life with diverse grains that thrive naturally. No sprays, no artificial fertilisers, no shortcuts. It's no chem, regen. Regenerative farming without chemicals. The result? Healthy soils, clean waters, flourishing biodiversity, a smaller carbon footprint, and whiskey full of flavour. Think warm, flaky pastry, butter and caramel. Fields full of life, whiskey full of flavour. Visit fielden.com, FIELDEN, and remember to drink responsibly.
Back to you, Daddy.
Karen Johnson, again, getting ready for today, we spoke about soil, not the idea of composting, putting energy in, but actually the idea of removing topsoil for construction and it going to landfill. And I wanted you to share a little bit about that.
Yeah, so I work in a Department of Engineering, hence me not being a biologist. And I'm trying to bring living soil, the notion of living soil, to engineering, because actually in our urban environments or wherever there's development, we are actually destroying soil. That's one of the ways that we're destroying soil, by sealing it. But also when we actually build houses or build a new tower block, we are removing soil, because you dig a hole, you put the tower block in, you have too much soil. At the moment in the UK, and I know it's the case in many parts of the world, the good quality topsoil is taken to landfill, and our landfill, we landfill in the UK about 200 million tonnes of waste every year, and about 30 million tonnes, more than 10% of that is clean topsoil. A lot more is clean stones as well, stuff we should not be putting in a landfill. And the reason the developers do that is because it is cheap. And it's not classed as a hazardous waste, which, of course, soil, unless it is contaminated, is not hazardous. But when you put it in a landfill, it is hazardous because it produces methane. And methane is a much stronger greenhouse gas than carbon dioxide. So it's really bad for the planet. So governments around the world are wrangling with that, trying to solve that problem of directly reusing the soil. Of course, you have to check that it is a healthy soil, and we've been around that conversation around that block. It's not as easy. It's easier said than done. We haven't got the right soil health tests yet in order to check it economically feasibly, as it were. But yeah, that is definitely a problem that we need to solve, because we have this beautiful resource which takes a long time to get established. We can discuss how long, but we are putting it into landfill, which is causing more harm to the planet and also costs more money than being able to sell it very cheaply or give it away for free to your local farmer, who might actually not have enough topsoil and want some either of a different texture, like Ray was talking about. You can change the soil texture, you can change it with the soil biology, but you can also, if you've got a very clay soil, which we have a lot of in the UK, especially in the north where I live, you can add a sand element to that soil and open it up a bit, which makes it easier for the biology to work with it. So yeah, there's so much work to be done in urban soils.
Yeah, well, thank you so much for your work exposing that and teaching us that is a thing. And I really hope that we can figure out a way, maybe through education to the farming community, about how important soil is, that becomes something of value to make it more commercially viable for, the construction industry. Ray, I was wanting to ask you about when farmers are thinking about putting energy back into the soil through composting. I've heard you talk about the Johnson Sioux, and I wanted you to explain what that is in layman's terms so that we can all understand.
Thank you, Richard. And before I do that, I want to just make a comment that Karen did. And in fact, all of us have a common thread here. It's about education. And Karen, I worked for USDA designing irrigation systems. And so I had a lot of engineering background. So the thing is, when I first started my career, one of the biggest problems we have, Richard, all over the United States is continual water leaving the land in a very angry way and we're having to build more dikes. We're having to build higher. And it was interesting when working with hydrologists and engineers, they focused, well, we'll just make the dikes bigger. And it was really about what Andy Neal was talking about. No, we need more aggregates. We need more infiltration. And so you have these huge landscapes because we do not understand our soils. And what Andie Marsh and all of us are doing here, if you don't understand the power of the aggregate and the biology, we're having this destructive flooding. We're having this destructive drought. Who would have thought of all of this? It comes back to the aggregate and how important. And so, Andy, before I go to answer the question with Johnson Sioux, do you know Dr. Johann Six? Or maybe all of you guys know him. I call him the father of the aggregate. I mean, I read all his literature, and now I know that Andy's all into this aggregate. But the reason I'm saying this, okay, so why the Johnson Sioux? Well, Dr. David Johnson, I went to school at New Mexico State University at the land grant, and Dr. David Johnson was teaching and was a professor at New Mexico State. And I wish he would have been my professor, but he wasn't. But the Johnson Sioux his wife's name is Sue, and David Johnson. And they created this very simple bioreactor based on vermiculture. So you take the carbon substrate that you have locally and let the earthworms transform it, and you keep it at a certain moisture. And so now, Richard, we're doing that in a huge, large scale, and we're spraying that amazing biological manure, if you could call it, or the liquids of the byproducts of life, storing it, and we're putting it in the pivot. We're coating the seed, and we're putting it in large sprayers, and we're doing it on thousands and thousands of acres. The Johnson Sioux bioreactor, we're using it as a fertilizer, but also an inoculant. And guess what we're finding? We can grow, and I've replicated research for 3 years under a pivot at Arizona. David was able to get the same yields without nitrogen fertilizer, just the vermiculture liquid. And we're going, whoa, can you imagine if we could fertilize our fields with just cover crops in a system of no-till cover crops and earthworm poop, the liquids of life? If we never saw another pound of fertilizer man-made on the planet, I would be tickled because farmers are going broke. So this is where we're using the power of life. And you would never think such a little amount of liquid could transform a field or save farmers millions of dollars. So that's what the vermiculture is kind of. The Johnson Sioux is a very passive compost, and Andy knows that. And so I love it, but we've now scaled it up on huge warehouse size, so we can spray it on 35 to 50,000 acres at a time. So we're doing that for farmers, and this is where we're heading. How do we get away from chemical fertilizer? And we're also being able to transition to non-GMO corn and change the wheat populations just by spraying that amazing biological byproduct onto the fields and coating the seed. Very cool stuff.
I love it. I love it. And I also adore your passion when I hear you talking about things like that, Ray. It's very infectious.
Sorry, I just get so...
And just to share with listeners, we're recording this at a little after 7 a.m. here in Texas. So I guess the early bird catches the worm. The worm comes from the soil. Anyway, Andy Neal, coming back to you. I wanted to ask you about the work you're doing in the UK with Wild Farmed and the Green Farm Collective, with friend of the pod, Tim Parton, especially when we're talking about regen management and the effects that has on the soil. So perhaps you can share a bit about the work you're doing there.
Yeah, well, I've made a real conscious effort to work with farmers, and particularly farmers that are really have a passion about their soil, for a number of reasons. And then I guess the original driver for this was if you look at the history of soils research in the 20th century, a lot of that was really quite pessimistic, looking at the losses of organic matter from soil because of a lot of ploughing going on, and because as farmers came to rely more and more on inorganic fertilizers, they forgot that organic matter is important for the soil in and of itself. And so, the science generated during the 21st century, the 20th century, a lot of it was about the consequences of losing organic matter from soil. But, sort of several years ago, probably getting on for a decade now, it became apparent to me that there was a group of farmers that were thinking differently and were looking to increase organic matter in their soil. And that, I thought, there's a great opportunity to be much more optimistic as a soil scientist, to look at what happens to soil as organic matter increases, because a lot of the previous research was not focusing on that. So it became apparent that it made sense to work with these farmers that were particularly interested in their soils. And of course, farmers will always be much better at doing this practically in the field than a research organization such as Rothamsted. So it made much more sense to be working directly with those farmers and understanding what was going on in their fields. So yes, we did a piece of work with Tim to try and understand the consequences of soil structure and organic matter for glyphosate degradation. And we particularly were comparing that, again, using X-ray computed tomography with my colleagues at Nottingham, to understand the trade-offs between soil disruption from ploughing or trying to disturb it as little as possible, but of course that being dependent upon glyphosate. So my general theory there is that a better soil structure, a more oxygenated soil structure, will allow glyphosate to be broken down more rapidly. And that's indeed what we saw in that work we did with Tim, that in some of his soils, glyphosate was broken down within 2 weeks. The work's not finished yet, but yes, the general hypothesis is that in very poorly structured soil, where there's very little oxygen availability, that glyphosate will persist for much longer. But Tim's soils have a very good structure as a consequence of his long-term, very careful management. And it's hard to say it was broken down completely, but it was below the detection limits of the instruments that we were using. We were using mass spectrometry. So it's quite sensitive, and it was below those detection limits. So understanding that the consequences for soil structure is really important for all sorts of things, but equally for looking at the degradation of herbicides where they have to be used. With Wild Farmed, I'm particularly interested in understanding what their above ground diversity, because of their bicropping and their having several different crops in the field at the same time, understanding what that is doing for below ground diversity of microbes, archaea and fungi. And that's a longer project, but equally soil structure will be important. Understanding what all that diversity of roots is bringing to the soil will be just as important. So yeah, it's really keen, I think, as scientists, that we work with the leading innovators in the field who are doing a very good job. And I think, yeah, equally as important is actually then feeding back the results so that they can learn and act and change their managements accordingly. So it's a great relationship that I enjoy an awful lot.
Yeah, and I think that's obviously really important to look at both the practices as well as the outcomes and having some kind of way to measure. Ray?
chime in.
Can I share a little blasphemy to the group? Look, our country's huge. Our deserts are getting bigger. About 20% of the land has no vegetation on it terrestrially. I would argue that agriculture, and I'm talking about grasslands and cropland all together, if we would bring living plants back into the system and use cows and animals, I think we could address a lot of our climate issues, and it would be the cheapest way of doing it, because some of the concepts is the most ridiculous concepts I've ever heard in my life, like getting 10,000 airplanes and try to alter and get more cloud cover. That's so dumb. I can't handle it. But we have that kind of thought process going on. Why don't we just cover it and bring cows and back? Do you know that we're restoring the Chihuahuan Desert? The Chihuahuan Desert, like what the Spaniards saw where I grew up in New Mexico, is coming back with cows. We can restore the planet a lot faster than we ever imagined. But it all comes back to what Karen and Andie Marsh and Andy have been saying. We need massive education about the soil. The way soil was taught is so poor, so boring, so disgusting that we walk around with professionals that do not even know what to do with an aggregate, don't even know what an aggregate is. All engineers should take a soil ecology course, and everybody from high school on should be learning. We interface with the most incredible substrate, the most incredible living systems of soil. And we're destroying our planet because we don't even understand that. So the reason the blasphemy part is people say, well, what do you mean, Ray? You mean agriculture can do a majority of the heavy lifting? Yeah. If you drive around the land, our country is huge. And most of it is bare after cropping season. There are millions and millions of acres after corn and soybean. They're bare. Looks like the moon. And we wonder why we're having problems. It's just ridiculous. And so that's our passion I think all of us have here. And, you think that Andy Neal's research doesn't mean anything, but it does. It's so important. And what Karen and all of you guys are doing, it's like, whoa, it's kind of like, I just want to scream and run in front of the highway and like, hit me because this is so dumb, because.
I want to join you with the screaming, not with the running in front of the cars, but I get so frustrated when I think that, it's just taken for granted. Everybody for hundreds of years accepts that we have to learn the 3 R's, reading, arithmetic, and writing. And now, actually, I think in our country, for 20 years, we've had financial literacy. And I can understand why that's important and that's taught. But it's all disconnected from nature. There's no legislation. There's no legislation around our national curriculum to say people must be taught about planet Earth, and soil is the 6 inches of stuff that's keeping us alive, as we're all keen on. It's just ridiculous. So I really join your passion, Ray, in that. It's
as part of this work, Ray, we've been using satellite imagery to capture above ground energy capture, primary productivity, and just to give you an example of what you're saying, on a Farm Ed, where we've been looking at their cereal and their pastures, the pastures are capturing twice as much energy as the cereals are, just because of that for a large period of the year. The soil is bare, and actually the problem we have here in Northern Europe is, as our crops are senescing and going dry, we've yet to get the maximum amount of insolation in the country. So we completely miss that, the greatest amount of sunlight and the most intense sunlight. Down here in Devon, where we've done similar measurements, our pastures are collecting probably 3 times as much as our cereals are. So there's a huge amount of energy that is just not captured by living plants above ground, just because of the very traditional way that we farm. We put a crop in and then we harvest it and then we leave. When all the sun's out and it's at its strongest, we leave that soil bare and there's nothing capturing that energy. Everything underground relies on that capture of energy.
And it's just being baked. I mean, I'm talking to you here from Austin, Texas, where it's very, very hot. And you look at the effect of, I've seen Ray and Alan Williams and others use an infrared thermometer looking at the bare temperature soil versus the plant literally next door to it. And the temperature difference is huge, to the point that the living organisms in the soil are getting baked and killed simply because there's no cover on the top. And that's why, I don't really like talking about weeds, but that's why they exist. That's nature saying, hey, I need some cover. Like, let's help each other out here. It's pretty crazy. And by the way, Karen, just quickly.
They're not weeds, Richard. They're not weeds. They're indigenous crops.
And Richard, they're the healers of the soil. They're forbs, and they're nature's healers. I think that weeds have a bad rap. And when we approach it that way, that we want to eliminate them, that is a horrible approach, and it causes that it's a battle that we'll never win. They're designed to be in the system. They're part of the system.
They're indicating. They're definitely a reflection of our management practices, right? So it's not that if you really go regenerative and you're operating within context, you're going to heal the land to the point that you won't have such high weed pressure, pest pressure. And that's really what we're after. I really like to think of this not so much as a climate issue as much as a human behavior issue. It really centers the source of the problem, which is that we are not in relationship. We're not in a healthy relationship right now with the environment, and it's our responsibility because we're being the abusive partner in that relationship currently. So we need to learn how to do the work of relating better, listening better, taking those notes, and responding with some amount of respect.
Andy, I think you hit it. Look, instead of looking up into the air, we should be looking down to the ground. It's what we're doing to the land. The climate would be fixed. Exactly. We're disconnected. And so if we could connect people, and this is why it's so polarizing in our country, it was the wrong approach. They meant well, but it's the destruction of the landscape and our attitude. Like Andy said it's our lack of love and respect for the land as the issue. And if we would have stuck with that theme all the way through, then there'd be no argument. And I think the moment you say climate is the most difficult thing to test. It's like your blood sugar. It moves every second. And that's why I don't even like to pay farmers for carbon. I think it's one of the stupidest ideas I've ever heard. And I'll tell you why. If you go to Arkansas, where it's hot and humid, it's cycling so quick, and they're doing all the regen practices. If you have a drought, carbon goes down. If you have a flood, carbon goes down. And you're paying for that? We should have always been about biodiversity. How do we cover it? Make it simple. We make it too complex. I have to deal with this on a large scale all the time, guys. And this is why I have two spectrums: the ecological groups, the environmentalists, and we have the farmers, and then we have everybody between the spectrum. And the confusion is brutal. It's brutal, and that's what we're stuck with.
But yet it's soil that is the connector between biodiversity and climate change. It's so like climate and nature, it's soil that is underpinning for both. And so but nobody's educated about that. So that is our job, I think. And that's why 6 inches of soil is so wonderful, because you're getting this message out there.
Yeah, and I wanted to add too, like, I really think we need to be building bridges. It's not about demonizing what we've historically done, or these hardworking farmers who are doing the best they can with the knowledge that they've had. This is why I feel very focused on doing work that contributes to a cultural shift, because that's ultimately what it's going to take, is that as a collective, we view the resource of the soil fundamentally differently than we have in the last 100+ years.
Yeah, exactly. And like farmers have only ever, you've got to go, Ray. Is that what you said?
I'm sorry I have to beg off, but thank you for your work. And I think, and thank you, Richard, for bringing this together, because you're bringing like minds together, and that we all have a passion and love for the land and for people. So thank you guys for what you guys do. And I got to go. And is there a way we can communicate with Andy and Karen that we get
Yeah, I'll set up. I'll set up a group. And yeah, thanks, Ray. You're an amazing human, and thank you so much for agreeing to do this. Yeah, love it.
Thank you for your service, guys. Together as a team. Bye-bye.
But Andie Marsh, just to respond to what you said, I think it's really important to not ever vilify farms and farmers, because all they've done is answer what we've asked of them. For the last 80 years, we've just been telling them yield is king. We want you to produce as much yield of whatever it is that you're growing, whether it's cattle, crops, whatever, at the expense of nothing. That is the primary focus. And they've done that, and they've used glyphosates and chemicals because that's what we've told them to do. And now, thankfully, we're starting to realize the error of our ways and trying to figure out how to, through education and consumer demand, companies like Wild Farmed putting products on the shelf that support this type of agriculture. So I think it's really important that we meet farmers where they are, and gradually, by giving them this extra information, that the work that we're all doing. Anyway, so yeah, it's just, I think it's an important point to make that I don't think the farmers are to blame. That's the opportunity to turn this around and fix it.
No, if I can add to that, I think the farmers are leading the way. So other Andy Neal said that we're struggling in academia to come up with the solutions just now. There's hope, but it's farmers who are leading the way by getting their hands dirty and actually learning what produces the best yields, because it's so complex. So yeah, no, farmers are the champions here. We all sleepwalked into, we were feeding the world, of course, and thought we were doing the right thing, but we now know better.
I'm also seeing in my work is farmers that feel responsible for the next generation. So family farms that have been on the land for generations and want to keep that in the family feel much more inspired by the regenerative movement and motivated to figure it out for their own land than, say, companies that manage land. So there's large agricultural companies that are even more, it's less intimate to them because they're either leasing the land or they're outsourcing the labor. And so they don't necessarily have that family connection or intimacy that would incentivize them to be good stewards of it.
Yeah. Well, guys, I want to be respectful of your time. I'm really grateful that you joined us today. Maybe do you each want to share one kind of final thought that you want listeners to think about and that they can take action on? But yeah, I guess one by one, do you want to just share kind of closing thoughts and things that you want listeners to think about?
Yeah, so I would really advocate for people to think about soil, to touch soil. So you've got to get out there into the forest and touch the soil. We know the forest soils are healthy if the forest's been there a long time. So touch the soil, get your hands dirty, and think about the soil. So make a terrarium. Which is I brought my terrarium to show you my pretty one. I've got lots of non-pretty ones which are full of microbes. They look like Winogradsky columns, Andy. So they're not so pretty to other people, but they're full of microbes. They're great. Yeah, lovely for the microbiologist. But really, the kids say go out and touch the grass. It's a saying that they say when they've been doing screen time too much. But I would say go out and touch the soil. And we like to turn, at Durham, we like to turn the saying, a nation that destroys its soil destroys itself, on its head, and say a nation that rebuilds its soil rebuilds itself. So work with the biology and we can rebuild it for everybody's health and wealth.
Yeah. Here. And what about you, Andie Marsh? What are your closing thoughts?
Yeah, I mean, I would also emphasize having a personal practice of some kind. So finding your way into the conversation is the hard part, right? And then you'll just keep pulling on that thread. So for some, it might be food and getting more interested in where you're purchasing your food and how it's grown. And making food, and that could be your in, or it could be composting, or it could be gardening, or it could be hiking trails and getting more immersed in nature and more familiar with your surroundings. So yeah, I just encourage people to cultivate a personal practice and get curious, and also have hope. Like a lot of the challenges that we face today, they became our reality in a relatively short period of time, and we could make a new norm in a relatively short amount of time. It's going to take all of us, though, and to establish that new norm.
Yeah. Wow. Powerful words. And I fully agree with what you're saying. And how about you, Andy Neal? Final closing thoughts?
Just drawing on what we've spoken about here from my experience, it's very difficult to imagine that soil is full of holes and that those holes are really important. But they're important for oxygen, for water storage, as a habitat for microbes and the microbiology and the larger biology in soil. So I'd leave this with our listeners. It's difficult to imagine that it's there, but it's fundamentally important to how your soil is working. And we know that it responds to energy input, plant products, root exudates, biomass that's left in the soil and goes through that whole sort of food chain. So the way of managing that is to ensure that there's organic matter going into your soil as often and as for much of part of the year as possible. Doing that will guarantee you an improvement in the way your soil functions. So I really appreciating that soil space, pore space is there, I think is the most important thing I could leave here, and just how important that is for the soil to function as effectively as it can.
Yeah, I love it. Well, thank you all so much for your time. We deeply appreciate it. And especially, as Ray said earlier, for all the work that you're doing in your communities around the world. It's much needed. It's really important. And we definitely appreciate that. So thank you very much for joining us today. And we will see you all next time. Well, now we're going to try a new feature of the podcast, which we're calling Ask Andy. And we've got Andie Marsh. And what we did in preparation for the recording today is we got some questions in from kids. And so I'm going to play the first kid question, and perhaps you can share your thoughts as to the answer. So here's the question.
Can you teach me about worms?
So Andy, can you teach us about worms?
Gosh, there's so much to learn about worms, but to spark your interest, worms are primary decomposers. So they help us recycle organic matter. If that's coming from leaves from a plant and it drops its leaves, I'm sure as a kid you've noticed that plants lose their leaves. Sometimes they die back and then they come and then they return to their vibrant green. And there's little creatures below ground, worms being one of them, that help recycle that matter and turn it into rich soil. They're also, if you think about the shape of a worm and how it moves through soil, they are really good at creating pore space, which we love because that's little pockets for habitat for other organisms. And that allows air and water to move through that soil. So those are just a few of my favorite things about worms.
That's really great. I love that. And I often see they come to the surface, I guess, when it's raining. Is that because the water kind of gets into their little pore spaces? I know that's a time when my kids tend to find them.
Yeah, and you can see them kind of scatter on the sidewalks and stuff, which is always sad. You can always help a worm along by putting it near your compost pile on a day like that. So yes, when their pore space becomes waterlogged, they look for drier ground, and that often makes them come to the surface. And sometimes that's great, and they'll burrow back in, and then other times they kind of get stuck in places like that, pavement.
The next two questions come from my own two children. So it's a back-to-back question. It's a double header. So you've got Oscar speaking first, who's 7, and then Tilly, who's 9, speaking. So here are their two questions.
What do worms have to do to help plants thrive?
And
what's the difference between healthy soil and unhealthy soil?
Very good. Okay, so remind me, it's Oscar and...
Yeah, Oscar and Tilly.
Tilly. Great. I'll start with Oscar's question. Also on the topic of worms. Another fun fact about worms is that they help make nutrients available to plants, and they can really promote what's called biodiversity below ground because they're their guts have a very healthy microbiome. And as they process organic matter and create castings, which is a fancy word for worm poop, that becomes plant available nutrients for all of our favorite vegetables and native plants that we have in our gardens. And as for Tilly's question, what's the difference between healthy soil and unhealthy soil? That's such an important question. And I always try to emphasize that it's healthy soils that provide a lot of the benefits that we talk about, whether that's as a carbon sink or for water infiltration, which means that we have more resilient landscapes during times of flooding or even times of drought because we have the reserves. That soil, healthy soil, it kind of acts like a sponge, whereas unhealthy soil can often act like dust that just either blows away in the wind or gets compacted down and is sealed off. So those are the biggest differences. Is one is thriving with life. Healthy soil has a lot of life in it and behaves like a sponge, whereas unhealthy soil behaves like dust and dirt and doesn't cycle nutrients to plants.
And how do you make soil better? I mean, one question we got posed on our Instagram post was, is it worth buying worms? Is that something you can introduce to the soil, or do you somehow make the soil better, maybe through how you're planting it, how you're treating it, and then worms kind of magically appear?
Mm-hmm. I would say taking a build it and they will come approach is my favorite approach to this. A lot of times the worms that you can purchase aren't going to necessarily thrive in your local environment, or in the worst case, they might actually become an invasive species that competes for resources of a more native worm. So we want to be careful about that. If you purchase worms for composting, that's kind of different because you're typically containing them in a space and using a type of worm called a red wiggler worm. But for the most part, when we're talking about soils, we're really just trying to improve the soil health so that worms want to hang out there and themselves contribute to even healthier, more vibrant soil systems.
Yeah. Okay. And then we've got one last question that comes in from little Ella. Let's see if I can get this one to work.
What does it mean when there's a lot of roly-polies in my house?
So her question, and I know her mum very well, and her mum has lots of potted plants around the house. And so Ella's question is, what does it mean when there are lots of roly-polies around the house, which in the UK, these are called woodlouse, but my kids are obsessed with roly-polies. So what can you teach us about a roly-poly that maybe we didn't already know?
Roly-polies were really my personal introduction into being interested with nature because they are everywhere and they're slow enough that you can play with them. Pick them up and return them, where you found them. But roly-polies are essentially primary decomposers. So they're like the shredders of our landscape. So when we're talking about those leaves falling from trees or plants dying back during winter, roly-polies do a great job of making those bits of organic matter smaller and available for more microbial life to degrade into a rich soil. So it's a very positive thing when you see lots of roly-polies around. They're just doing their work of getting that organic matter back to the earth.
Okay, that's a really good answer. Thanks for sharing that. And then last question. This comes from me and our own household. We think a lot about composting, and some of our friends have these machines that sit in your kitchen where you can put food waste in, and they kind of turn it into this like brown soil-like stuff. Can you just give us some brief highlights on composting at home, things that are good and things that aren't good? Because that's always good to know about.
Yeah, my take on these countertop compost bins is that they're useful in the sense that they immediately grind up and dehydrate the food waste that you might be producing in your kitchen. But it's important to realize that that itself is not truly composting. You're not ending up with a very biodiverse, microbially diverse soil amendment at the end of that. So I think that those can be useful in basically creating a shelf-stable feedstock that you would then put into a compost pile. And composting does not have to be complicated. It can literally be a heap on the ground. And you're more or less balancing carbon to nitrogen. So my rule of thumb is when you initially build a pile, you want it to be about 2/3 carbon input. So that could be wood chips, shredded leaves, paper products. And the other third would be nitrogen rich products. So that would be like food scraps, grass clippings, and those sorts of things. And then every time you take out your food scraps to the pile, go ahead and add an equal amount of the carbon, and that'll keep it balanced long term.
Oh, yeah, I love that. And I also, it bothers me a lot when we see gardeners in our neighborhood taking away all of the leaves and the grass clippings and stuff. And I really wish they would keep them there. But that's really good advice. And I guess the last question on composting is, how long should you be leaving it in the compost pile before you can start taking it out and spreading it, on your rose beds and things?
Basically, once it's at ambient temperature, so it's no longer hot, and you can stick your hand in there and feel it, and it's more like the consistency of soil, you can go ahead and use it. So there's really no harm in, as long as it's not hot, essentially, or super chunky, then in that case, that you have more decomposition to go.
This is amazing. Well, that has been Ask Andy. Thank you for your time and your expertise. And I'm sure those kids will be really happy with those answers. And thanks for engaging with them and with us, and for being a superstar guest.
Thank you.
Wow, what an episode that was. I think if anyone's been anywhere near me in the social conversation for the last 5 years, you will have probably been so bored of all of the soil chat. And so for me, it was very exciting to be in a kind of cauldron of soil with so much energy bouncing around. What do you think of that episode, Claire?
Well, I think you just summed it up. It was live, like very healthy soil. You could feel the vibrations, which if you put your feet gently on and you were subtly tuning into life under your feet, you'd feel that every single one of them is very passionate. And I'm not sure I would have said that 5 years ago, that I'd talked to a scientist, and sorry, all of those scientists, but sometimes I think everyone gets sort of in their amazing specialities or those specialist areas. I think they get very excited, but to hear the scientist who's left the lab, who's been on the farm, who's felt the soil, I think they interact with a thing that's out there every day. I mean, for me, when and we're not, this is a real Blue Peter moment, we're not recommending you going to try this at home, but you can, the caveat of it being in a clean forest floor. But Karen goes to a clean forest floor away from any dog that might have been there or whatever, digs under, gets herself, and even has a little taste and a smell. For me, I've just done this. I'm doing a regenerative course. I think I've alluded to it before. And this is a thing for people to look into. It's called wood duff. Now, wood duff is the forest floor, vibrant with fungi and everything, and you smell it. So when I was going through this, and then you mix it with molasses and rainwater, and you let it ferment, and those microbes that are on that forest floor and that life and the fungi come together, you let it sit there, and you basically create your own biologically active fertilizer. And so doing that last week reminded me when I've heard Karen or re-listened to Karen, it was that incredible connection, and that's what you hear from her, but all of them.
Yeah, and especially the change that someone like Ray has gone through, coming through all of his studies back in the day and thinking of soil as a fixed thing with fixed nitrogen levels, and actually realizing that all of the teachings are completely wrong and that it's very mobile, and just listening to the journey. And I would encourage any listener who's interested in this to search Ray Archuleta. There are lots of amazing YouTube videos that he puts out just on the journey that he's been on, and some of his teachings, they're really interesting. And he's got so much energy. I referenced this on the episode, but we recorded it at 7 o'clock in the morning, and maybe he'd had like 16 coffees or something, but he was just like, whoa, okay, hi Ray, let's go. So that was fun. And it's always fun to talk about underwear, white cotton underwear on the podcast and burying it in the soil, but that's something quite fun you can do with your kids. I especially, having got a couple of kids myself, I really appreciate all the work that all of them do, and especially Karen with the connectivity of going to the 8-year-olds, the 10-year-olds, the 12-year-olds, and really helping them understand about soil, what it's about. And I really enjoyed the points that she made on that. Yeah, it was a good episode, especially with our name being 6 Inches of Soil. I think it was overdue that we do one on that.
I think we'll do more. And the other thing for everyone, we actually filmed with Country Trust, who are in the film. The kids are in the film, and we showed a scene of the pants being dug and then them being dug up. And we didn't put them in the film because it kind of needed more explanation. It was another rabbit hole to go down. But now we're going to be able to use the footage. So my colleague at the moment is delving through to try and get those. So I'm hoping we'll be able to share those on social media in connection to this episode. That is a very real citizen science project. So anyway, I just hope everyone really loved it, because I personally love the connection now that the scientists and the scientists are looking to the farmers are looking to the scientists, and other people are getting involved in this. So it's a very beautiful and exciting space to be. And we will do more on soil. We'll have more podcasts in different veins and look at compost and maybe microbes, just a whole thing on microbes itself. There's just so much to talk about there.
Yeah, and especially I think the rainfall infiltration test, which Ray references, I know Groundswell last year, well, they had the same demo this year, but I took my parents to Groundswell last year, and that was the moment for them when they saw that demonstration happening. They realized the difference between a monoculture versus a very biodiverse landscape, and how the water doesn't actually sink into the soil of a monoculture and causes so much flooding and problems, and also drought, because the soil it's not able to hold the water in it. I think that there are so many aha moments, which is a really good way for people to get interested and really understand the benefit of good soil. So there's so much more to talk about, but thank you very much for listening. We really appreciate you. If you do have time to leave any feedback or give us 5 stars, that's always appreciative, and tell your friends. And until next time, we'll see you soon, soil mates.